We start new article, Newton's law of cooling. And the statement for the law is the rate of cooling of hot body is directly proportional to the mean excess of temperature of body above the surrounding, provided the difference in the temperature of the body and the surrounding is small. In simple word, we can write mathematical statement of Newton's law of cooling is. So we can write in term of theta or we can write in term of temperature also. You can see here. So here some object is cooling here. Now, so when the object is cooling, that time we can write here d theta by dt is proportional to theta minus or t minus ts. Or we can write the same way like this, d theta by dt is equal to or is proportional to theta minus theta s or theta 0. In that way also we can write, or we can write t minus ts. Now here T is temperature of body, Ts room temperature or surrounding temperature, room temperature or surrounding temperature. D theta by dt it's the rate of fall of temperature, rate of fall of temperature. So we can write rate of fall of temperature directly proportional to. So in another word, we can like this way also. So d theta by dt, rate of fall of temperature, and T minus Ts we can write T minus Ts. T means temperature of body minus temperature of surrounding. It is the excess temperature over surrounding. And in that way you can write the law, this d theta by dt, rate of fall of temperature directly proportional to T minus Ts means excess temperature over surrounding, provided that this excess temperature must be small. And this is a statement for Newton's law of cooling. I hope everyone understood. Now here we can write constant. Constant we can write anything. We write K, we write C, it doesn't matter. So d theta by dt is the rate of cooling. Then T and Ts are the temperature of body and temperature of surrounding. C is the constant of proportionality. Now here one question based on this article is, Newton's law of cooling hold good provided the temperature difference between the body and surrounding is. The temperature difference between body and surrounding means T minus Ts, and it is also called as excess temperature. And the excess temperature here must be small, then only this law is hold true or hold good, only when this excess temperature is small. Now here you have one practical in the 12th standard, in that you have to do Newton's law and you have to verify it. So in that you have to draw a temperature curve for object. And so you have to take hot object that you have to cool, you have to note down a temperature and time. Then you get this type of cooling. This is temperature axis, this is time axis. As time passes, this temperature start decreasing exponentially. Now this type of graph you get, and you have to find out slope of this graph by using that. You have to verify the Newton's law of cooling, as well as you have to find out room temperature also. It is in the practical part of the 12th standard syllabus. I hope but here Newton's law is clear for everyone. Only the thing is you can remember mathematically d theta by dt proportional to T minus Ts. This is rate of cooling and this is the excess temperature. Yeah, rate of fall of temperature directly proportional to excess temperature. That is the Newton's law. And provided that excess is small. Now see the next question here. The curve drawn between temperature of a body and time is known as, here it is known as cooling curve. So temperature versus time is called as cooling curve. Now here all the articles from chapter is over. Now we have to start problem based on this chapter.